All right, diving right in today, we're tackling a topic that's pretty much unavoidable if you're aiming for those senior software engineer roles.
Yeah, definitely a big one.
Asynchronous communication and microservices.
You got it.
It's all about building these complex systems where, you've got all these different parts that need to work together,
Right.
but you don't want them to be held back by waiting on each other all the time.
Absolutely. That's where asynchronous communication comes in. It's how we build systems that can handle a ton of stuff and stay strong even under pressure.
So basically, it's how different parts of our system can talk to each other without needing an immediate response.
Exactly. One service can send off a message and then just keep working instead of just sitting there twiddling its thumbs waiting for a reply.
Right, so it's a pretty different way of thinking compared to that old synchronous way, where you make a call and then you're stuck until you get an answer back.
Definitely a shift in how we approach things.
Okay, so let's get down to brass tacks here. Let's say we've got an e-commerce platform, those websites where you're adding things to your cart, hoping it all goes
Oh,
smoothly.
yeah, we all know those.
So let's zoom in on how the order processor, the part that handles your order and makes sure you pay up, talks to the warehouse service,
Okay.
the one that's actually got to find your stuff and get it ready to ship.
That's the part we often talk about when we're designing systems. So when an order comes in, the order processor has got to let the warehouse know, hey, get this order moving. Now just imagine if this was done synchronously. The order processor sends the send package message, and then boom, it's stuck. It can't do anything else, no other orders, until the warehouse is completely done with the whole process.
Finding the stuff, packing it all up, and scheduling the shipment.
The whole 9 yards.
And that whole process, that could take hours, right?
Right.
Even a day or two, maybe.
Easily. The warehouse team has to find your stuff, pack it carefully, make sure it's all good to go, and then figure out how it's going to get to you.
If the order processor is just sitting there waiting the entire time, the whole system just grinds to a halt.
Pretty much. No new orders can be taken, nothing. Not exactly what you want, especially on a busy day.
Like Black Friday, yeah, that would be a disaster.
Exactly. That's why asynchronous request response is so useful here. The order processor sends off that send package message, but then it immediately gets back to work. It can handle other orders, process payments, all that good stuff. It's non-blocking, so it doesn't get stuck waiting. Then, when the warehouse is all done with its part, it sends back a package sent confirmation.
Okay, I see.
And that confirmation comes later, completely separate from that initial request.
So the order processor keeps on trucking, handling everything else it needs to do.
Right.
It just needs to be ready to deal with that package sent notification whenever it shows up. And that difference between having to wait and being able to keep working, that's a super important thing to get for anyone going into those senior interviews.
Absolutely. Interviewers want to know if you get how using asynchronous communication makes things more efficient compared to that simpler synchronous approach. And they want to know if you understand how these different styles affect the overall system performance and how well it can handle things when things go wrong.
So understanding those trade-offs is key.
Definitely a key takeaway.
Okay, so we've got a good grasp on this asynchronous request response thing with our order example.
Yeah.
But there are a few other ways these non-blocking interactions can go down right.
Yeah.
What other common patterns should we know about?
You're right. There are a few others. We've got communication through shared data,
Okay.
request response, but in a broader way than we just talked about,
Okay.
and event-driven interaction.
All right, so shared data first. What's that all about?
So this one's where one service updates some information that everyone shares, and then other services can see that updated info whenever they need it. Like, imagine you have a service that keeps track of all the products and their prices. If the price of something changes, that service updates the info. Then let's say you've got a shopping cart service and a recommendation engine. Both of those can see that new price the next time they need the product details.
I gotcha. So it's not so much about direct messages back and forth.
Right.
It's more like everyone's looking at the same up-to-date information.
Exactly. Think of it like different departments in a store. They all check the same inventory list to know what's in stock.
Okay. Makes sense. It's like updating a big spreadsheet that everyone can see.
Exactly. And then there's request response, which we saw with our order situation.
Right. We talked about that. But you said there's a broader way to think about it.
Yeah. So the basic idea is still the same. One service asks another one to do something, and eventually it gets a response saying whether it worked or not. The important thing is that the service that made the request, it doesn't just sit there and wait.
Right. It keeps working.
Exactly. And another important thing for making things scalable and reliable is that any instance of that service should be able to handle the response when it comes back.
Okay, so it doesn't have to be the same exact instance that made the request.
Right. So if one instance of the order processor sent the send package message, any available order processor instance should be able to handle that package sent notification when it arrives.
So it's about spreading the work and making sure things keep going, even if one part of the system has a little hiccup.
Exactly. It's all about spreading the load and building in some backups and redundancy.
Makes sense. And then the third one, the event-driven interaction.
Right. That one's interesting. It's all about broadcasting events. An event is just a notification that something happened, like a statement of fact. So,
Mhm.
for example, after the order processor successfully charges the customer, it could send out an order-created event. And then other services that care about new orders, like maybe an analytics service that tracks sales or a service that sends out confirmation emails, they can all listen for these order-created events and do their thing. The order processor doesn't need to know who's listening or what they're going to do with that information.
So it's like putting an announcement up on a bulletin board, and whoever's interested can see it.
Exactly. It's like publishing an article. Anyone who wants to read it can.
Got it. So what are the big wins for going with this asynchronous non-blocking way? It seems like it adds a bit more complexity compared to just making a direct call and getting an answer right away.
Oh, the advantages are huge, especially when you've got a big spread out system built with microservices. We've already talked about temporal decoupling, where the services don't have to be up and running at the exact same time. This makes the system much more resilient. So if the warehouse service is down for a bit, the order processor can still keep taking and processing orders. It'll just retry sending that send package request when the warehouse comes back online. It's like building a ship with separate compartments. If one compartment gets damaged, the whole ship doesn't sink.
Right, the whole system doesn't just crash because one part's having a little trouble. And we saw how it's good for those long processes, like our shipping example. It wouldn't make sense for the order processor to just stop everything and wait for hours or even days.
Exactly. And asynchronous communication can be a real lifesaver when you've got these long, complicated chains of calls between different services. If service A calls B, then B calls C, then C calls D, and so on, doing that synchronously can get really messy and hard to manage.
It's like a big chain reaction where one thing depends on the next.
Right. Asynchronous communication helps break those chains and makes the system more flexible and easier to maintain.
So you're saying it's more adaptable and less likely to completely break down if one part's acting up. Okay, so asynchronous communication sounds like a bit of a superhero for microservices in a lot of cases.
It definitely has its strengths.
But every superhero has their weaknesses, right?
Mhm.
What are the downsides, the tricky parts we need to be aware of?
Yeah, it's not a magic solution for sure. The main challenges compared to synchronous communication are that it can be more complex, and there are a ton of different patterns and technologies out there.
Right, we talked about different styles like request response and event-driven.
Exactly. And figuring out which one's best for a particular situation can be tough. It's like having a huge toolbox filled with specialized tools. You got to know which tool to use for each job.
Having too many choices can be a problem for
Yeah.
sure. And I bet if you're used to thinking about making a call and getting an answer right away, this whole thing about sending a message and maybe getting a response much later, or maybe not even a direct response at all, that can be hard to wrap your head around at first.
Absolutely. There's definitely a learning curve involved, especially if you're not familiar with asynchronous programming. And then when you start getting into the nitty-gritty of it, the message queues, the brokers, the event buses, all those technologies have their own complexities and potential problems.
It sounds like there's a lot to learn.
There is. And making sure messages are delivered properly, handling errors gracefully, and keeping everything in the right order can get more complicated.
Right, so you're trading some initial simplicity for more flexibility and resilience down the road.
That's a good way to put it.
Okay, one thing I came across while I was prepping for interviews was this thing called async-await. It sounds like it's all about asynchronous operations,
Yeah.
but I read that it can still block.
Yeah, async-await. It can be confusing.
Yeah, it seems kind of contradictory.
It can seem that way. Async-await, you see it a lot in languages like JavaScript. It's designed to make working with asynchronous operations feel more like your traditional synchronous code. You use the async keyword to define a function that's probably going to do some asynchronous stuff. And then inside that function, you use await before a promise. You can think of a promise like a placeholder for a value that's coming later.
So it makes the asynchronous code look neater, kind of like you're just waiting for a value to come back.
Exactly. Like, let's say you need to get the latest currency exchange rates from another service.
Okay.
You might have an async function that starts that request. When you put a wait before the call to get the rate, it'll pause that specific function until the exchange rate data is back. So even though the actual process of getting that data is happening in the background without blocking the whole program, that line of code with await will wait until the promise is resolved. It's like having a super fast car, but then having to stop at a red light. The car can go fast, but at that moment, it's got to wait.
So even though we're not locking up the whole application, that specific part of the code with await is basically taking a pause until that asynchronous operation is finished. It's like creating a little synchronous island within our asynchronous flow.
Exactly. And this is something important to understand, especially when you're talking about system performance in an interview. Even though async-await makes asynchronous code easier to write and understand, it doesn't mean that everything becomes non-blocking. If you use await too much in parts of your code where performance really matters, you can still end up with bottlenecks. So even with all this asynchronous stuff, you got to be careful not to accidentally make things synchronous again.
So it's not a free pass. You can still mess things up.
Right. It's like having a fast car but getting stuck in traffic.
Okay, so that's a really important point. So for someone who's gearing up for a senior engineering interview, when should they be thinking about pushing for asynchronous communication in their system designs?
The main times are when you've got those long-running operations, like our order processing example. If something's going to take a long time, and you don't know exactly how long, blocking everything else is usually a recipe for bad performance and a frustrating experience for the user. And remember how we talked about those complicated chains of calls between services?
Yeah, where everything's depending on everything else.
Right. If those chains are hard to manage and could cause problems, asynchronous communication can be a great way to decouple those dependencies and make the system more resilient overall. This means your services can be updated and deployed independently without worrying too much about breaking other parts of the system because of temporary outages.
So long and unpredictable processing times and those tangled webs of service interactions, those are the big signs that we should think about an asynchronous approach.
Exactly.
But it sounds like there's no one-size-fits-all answer. It depends on what we need and what trade-offs we're okay with in our system.
Absolutely. There's no magic solution. You need to weigh the pros and cons. You've got the temporal decoupling, the better responsiveness for the user, and the ability to handle long tasks more effectively.
Right.
But you have to balance that against the added complexity, the learning curve for your team, and the potential issues with things like error handling, debugging, and monitoring.
Okay, so it's all about finding the right balance.
Exactly.
All right, let's wrap up this deep dive.
Uh,
We've learned that asynchronous communication in microservices is all about letting those services operate independently in time.
yeah.
That's super important for managing long operations and building systems that can handle a lot. We've gone through different patterns like request response and event-driven interactions.
Right.
And we even cleared up some confusion about how async-await works and how it can still block sometimes.
Yeah.
This is the kind of deep understanding that interviewers are looking for at the senior level. They want to see that you can really think critically about these architectural trade-offs and design systems that are both scalable and resilient.
Definitely. Being able to talk about the pros and cons of different asynchronous approaches and explain when you'd use one over another is a key skill for any senior software engineer.
Absolutely. So here's something to ponder as you continue your interview prep. Think about the systems you've worked on.
Okay.
Where could asynchronous communication have made a big difference in performance or reliability? And what challenges might you have faced if you implemented it? Take some time to think about your own experiences.
Good advice.
Thanks for joining us for this deep dive.
My pleasure.